So now there have been a lot of videos here in which we've discussed how to, first of all, just what are extrema, how to find extrema, how to justify extrema, and kind of what's the point of all of this? What does that help us do besides find maximas and minimas on our graphs? And this is where modeling and optimization comes in. So anytime you hear a mathematician say modeling, we're referring to writing one or more equations to represent a situation. So this is any time that, say, in a science lab or in any other situation where you've used an equation to say this equation is representing something that's happening in the real world. And then optimization is a very specific type of modeling where we're trying to find a maximum or a minimum in some real life situation, such as finding a maximum profit or a minimum cost. And to kind of just talk about how we approach problems like these, because mathematically, you've learned all the calculus you need to be able to do this. It's not the calculus that's difficult, it's the setting up of the problem to do the calculus on. So our general approach is, first of all, understand the problem. And I know this sounds very basic. You've heard since you were little kids, make sure you read the problem and understand what's happening. But what I mean by this is you need to identify what you're optimizing. In other words, what are you finding a maximum or minimum of? Because whatever you're optimizing is what you need to write an equation for. So if you need to find a maximum profit, you need to write an equation for profit. If you want to find a minimum surface area, say for creating a package, then you need to write an equation for surface area. If you need to find a maximum volume, then you need to write an equation for volume. That's what understanding the problem means. And then develop the model is to write the equation for what you're finding a max or min on. In addition to that, you may need to write what's called a constraint equation, because your initial equation you write for, say, surface area may have too many variables in it for you to find a maximum or minimum using the first derivative test or second derivative test. In which case, a constraint is another equation that you can use to substitute in for a variable in your model. Then if you happen to be allowed to use a calculator, you might as well graph the function and find the maximum or minimum on your calculator. If you don't have the calculator available, then pretty much just skip this. Then go through your first derivative test, which is what most people tend to do, which is figure out your domain so you can identify if there are any endpoints, identify your critical points where your first derivative is equal to 0 or undefined, and then use the sign chart and a candidates test to actually solve this. And then interpret the solution is, once you get the number at the end and say there's a maximum here, that's not the end of the problem. You need to go back and actually, I say, this is the relative maximum for this situation. In other words, tie it back to what you are specifically being asked. So a quick example here would be if we wanted to find two numbers whose sum is 20 and whose product is as large as possible. So in terms of first identify what it is we're optimizing. We want a product as large as possible. So we need the max product. So I'm going to use P for products, and I'm multiplying two numbers then, X times Y. Now the issue here is I now have too many variables. We know how to do first derivative tests if we had just X's or just Y's. But with two, we're going to need a second equation, and that's where the sum is 20, so I know X plus Y equals 20, and this is called the constraint. Because I can now use this to replace one of my variables in my product equation. I'm going to replace X. So I will now have P equals 20 minus Y times Y, which is the same as 20Y minus Y squared. In terms of my domain, I'm not really told anything about X and Y. I'm just told that they're numbers. So they could be any real numbers. I'm pretty sure they're both going to be positive, but that's not guaranteed. There's nothing here that says it has to be that way, because I could say 21 and -1. would add up to 20. I doubt that's my largest product, but it's still a possibility. But then I go to my critical points. So I need P prime, which would be 20 minus 2y. The nice thing is, it's never undefined. And then when I set this equal to 0, I get y is 10. So I really only have one candidate. When y is 10, my product will be 100. So I do a sign chart for P prime. And I'm plugging these into my derivative, remember? So something less than 10, if I say 0, this is going to be positive. If I plug something bigger than 10, P prime is negative. So sketching, P is increasing and decreasing. So I do have my maximum here. So that's really my only option. Now, in terms of what I'm being asked for, I can't stop there. This is interpreted in terms of the situation. In that, what I'm saying is we've been asked to identify two numbers, and I only have one. So two numbers are 10, which is the y, and then I need to find x, which when I plug that into my constraint, is also going to be 10. I'm not being asked what is the maximum product. If I were, I would be sure to include that. I'm just being asked what are these two numbers.